Good morning, good afternoon, good evening, everyone. My name is Amy Feldman, Director of Product Marketing for CA Technologies for our Application Performance Management Suite. I'm joined today by Nishant Kabra, Senior Principal Product Manager for APM. If you do have, just some quick logistics, if you do have any questions today, there's a Q&A field located in WebEx if you want to just go ahead and use that and submit any questions at any time during today's webcast. Today we're going to be talking about what's new in application performance management. Our last session we did for the communities was back in February, so we're going to do a quick recap of some of the new items that you will see, especially in the SaaS environment. So if you're not familiar, our APM SaaS environment, it updates about every 2 weeks. And so there's a culmination of features that were added within the July and August timeframe that we're going to go over today. Just some quick highlights that you'll see here. There was a lot of UI updates. You probably noticed if you log into the APM SaaS environment. There's new notebook views. There's a new transaction viewer. There was a lot of updates to the agents. We'll talk a little bit more about that as well. And then in August, there was a developer mode enhancement feature. So we're going to continue to add some developer enhancements throughout the product over the next couple months. And the first one is a line of code. So we'll show you some screenshots of that as well. There was some new APM Infrastructure Agent enhancements, as well as we're continuing down the support for modern applications. So building onto what we've done with supporting Docker containers and Kubernetes and OpenShift, we added Cloud Foundry. We had Cloud Foundry support prior, but we've done a lot of enhancements over the past couple months to improve support for Cloud Foundry, and then you can see some other supported platforms here as well. Nishant, you want to talk a little bit about some of the developer mode features that have been included within this last release?
Sure, yeah. So as, hi folks, so as Amy was saying, around so we did add a bunch of functionality around surfacing more information around, in addition to our instrumentation or the metrics that we get from instrumentation. So additional metrics around, for example, now you can also look at what is the CPU time, what is the exact execution time of a code, right? So in addition to response time, look at some of the CPU times for that method. A lot of times the method, if it's waiting on an IO call, the performance, it will show a poor performance in the response time, but until you see the CPU time, you're not going to know if it was the method itself that was taking all that response time, or was it because of say it was waiting on IO. So we added those. Line of code is another big one, which is also requested by a lot of our customers. So essentially, as you triage to a performance issue and you narrow it down to a say class and method, to also see now where exactly is that in your line of code. So essentially, so you can if you're a developer, then you can go and fix it, or maybe send that screenshot out to a developer, so they can go and exactly find that method, the line of code, and then go and fix it. And it is at different places. So you'll notice as soon as you open up a transaction trace to triage that issue, you will see the line of code as a part of the wedding cake view, or the inverted wedding cake view. If you're familiar, it's on the left-hand side of this screen, which essentially shows you a method called stack. And each of those methods have, as you notice, they have a line of code in there. Also, as you're aware, right, there are other ways to also navigate through this stack trace. So for example, there is also a tree mode, there is a summary view, there is a tree view, right? So the tree view is especially nice if you want to also go and quickly go down to a specific method that is that could be a bottleneck for that transaction. So, and again, even on the tree view, you'll see the line of code. Here are this screenshot has the system properties. As I was talking about earlier, these are all the CPU times. As you notice, there's a total CPU time, and also a breakdown across different CPU times, right? So for example, the user CPU time is the time spent in executing their method code. The system CPU is something that the kernel, the OS kernel took to execute it, right? So more often than not, if you see a high user CPU time, for example, that means that there is something definitely going on inside the method code that's causing that high CPU. Sometimes you'll also see like a wait time or a block time, right? If the method is making too many calls to I/O, for example, or calls to database, for example. So all of those will surface up in the CPU times.
And I think what's nice about this, Nishant, is many of our users will have noticed the addition of infrastructure metrics over the past over the past year. APM looks at user experience, so collecting data from a synthetic as well as from a real user perspective, also including information from AXA. We also include bytecode instrumentation, so that screen that Nishant was showing before, that produces a lot of that rich diagnostic information out of the application itself. And then last year we added an APM Infrastructure Agent. And so that gives us that ability to really start connecting APM into these back-end services and then further enrich the diagnostic details as well as the overall connection of user experience, application performance, and into those back-end supported systems. So I like this feature. I think it's pretty cool. Nishant, you want to talk a little bit more about how the infrastructure agent now plugs into assisted triage?
Yeah, absolutely. So, so our focus in the last few, months or, year, 2 years has been to also bring in some of the infrastructure data inside of infrastructure performance inside of APM. And this is essentially not just looking at, just monitoring from an infrastructure-wise, right? We know now the infrastructures have become really complex, especially with the cloud and the container world, right? There are several layers of infrastructure as you go up and down vertically, even in your application stack, right? So you could have, say a JVM process, which is more like an application process, and that could be running in a container, right? That could be running in a host. If it's deployed in a cloud, for example, then you also have, say, AWS or an EC2. So there's several different tiers in this infrastructure, right? And then also the approach that we are taking is essentially providing visibility at each of the different tiers, because it is extremely important to monitor at each of those different tiers of your application infrastructure. It is not just monitoring, right? So it's not just producing a bunch of metrics, but also correlating this infrastructure metrics with the application performance metrics, right? So if you're if your servlet is running poorly, if you see a slow response time, then being also able to quickly go and check, what are the containers memory at that point of time, right? What are the container CPU, or how was the host doing, right? Maybe the host was running out of resources. That can also have an impact on the performance of the app. So providing that correlation, and then the third piece is not just plain correlation, but also doing a causal correlation, right? So what I mean by that is, as with assisted triage, as you detect issues, performance issues with the app, also being able to see all the infrastructure events as a part of that assisted triage problem. And now, in our latest update of assisted triage, you'll also see infrastructure. If there was an infrastructure that could have caused that bottleneck with the app performance, that will also surface that infrastructure event as an evidence, right? And I'll show this in my video later, right, as to how, sorry, in my demo later as to how, then, how can you even, how you can even do like an impact analysis, because once you know that the infrastructure is, say, over-provisioned, for example, then, it's sure to affect, other services that depend on that infrastructure. And so I'll show in my demo, how do you go about doing something like that.
And all this is made possible because we have this really rich graphical typology. And this allows us to be able to quickly and very dynamically be able to pull in new sources of information. So we were able to support, Docker very quickly because of the flexibility of this graphical typology database that we had created. It looks at various different nodes and then the vertices that connect all the nodes together. So when you're looking at an application, it obviously consists of multiple different components. So we're connecting all of those various different nodes together, whether that be like a web server to a Docker container to, the underlying Node.js code underneath it, all the way to a backend, as Nishant was saying, a cloud service, maybe the instance running the container on an Amazon AWS instance. So being able to connect all those pieces together gives you then that really advanced correlation that you're able to do across applications down to the infrastructure. Because of the richness of the model and because it's a multi-dimensional time series model, time is a very important consideration within inside the model. It allows you then to be able to recognize those patterns within inside the environment and be able to almost tell like a narrative or a story. So it collects all these different stories about how the application is performing, all the connection points within that application, and all the underlying correlation infrastructure components as well. So now you're able to see all the patterns that occur. You're able to do you're able to apply, some types of machine learning to be able to determine, this is what assisted triage does, to be able to determine and look for certain characteristics that are common with certain problems, look for those characteristics within inside of the model and with side of the data to be able to then surface that up as a possible culprit. So that's what you're seeing here is you're seeing the possible culprits based off of the patterns and the intelligence that's built into the platform. So I can see the application is a culprit, has a potential problem, and then also there's an infrastructure component that is causing an issue as well, and you can see the alerts then that are associated with that. Because there is so much intelligence built into this layer, we have this what we call our notebook, our analysis notebook, and that's kind of like a detective at a crime scene that's looking for possible culprits and possible issues. And so what we're doing is we're pulling all the information together, but then providing that notebook to you so that you can then validate that, because a lot of people are still hesitant about, if we just gave you the answer, you'd be like, okay, well, show me the math and how you got to that answer. So that's why we have the analysis notebook, to provide that richness of data and to show you how we came to that problem. Nishant, you want to talk a little bit more about kind of the metrics and the drill down capabilities?
Yeah. So, as, we have those infrastructure events, and, the next thing that you want to then, also go and check is, what are the infrastructure metrics, right? What does the metric trend look like? So right below that view, you can click on the infrastructure component. As you know, right, as Amy was saying earlier, the model that you see is pretty dynamic, right? It includes all the relationships, not just from an application dependency-wise, but also relationships between the application to the infrastructure. And there are different contexts that you can switch right in that view. So you can go from an application context to an infrastructure context. So if you're looking for, if assisted triage is telling you that there is an infrastructure component also that is affected by that problem that you're looking at, then you can switch to the infrastructure context, and then down below for that piece of infrastructure, you can go and check the metrics, which is what you're seeing in this screenshot. So right here, I can go and check. You can go and check what the CPU utilization, for example, is, right? And it also maps this along with your the alerts and thresholds. So you can kind of see what the metric trend is. Right? In this case, for example, there was a spike around around a certain time, and that's the time when also the application was also experiencing slowness, right? So you have a direct correlation now that the CPU spikes, right? The app was experiencing a slowness, right? Now this could be an application code issue which could be causing a CPU burn, right? Or and then the next thing is if this infrastructure is running out of CPU, then what are the other apps or services that could potentially be impacted when this event occurs?
That's great. Hey, Nishant, before we head into our next slide around now having the infrastructure agent available as a Docker deployment, you mentioned something interesting about the model. So yes, our graphical typology model is highly sophisticated, and it does give you that capability to be able to pivot on various different aspects or metadata inside of the typology itself. And we have kind of this unique capability that allows us to define what we call attributes. And attributes can be defined as either the application or a component or an AWS instance, or you can't even create your own attributes. And it helps you to then layer on context to the content down below. And that really now allows you to be able to understand the data in a way that makes sense to you. So you can define an attribute based off of a data center. You can define attributes based off of developers. So Nishant, in this release, there was some kind of interesting enhancements around attributes. Can you talk a little bit more about some of those enhancements?
Yes. So, as Amy was explaining around the attributes, right? Attributes are really, especially with so many tiers in your application infrastructure, there is so much of metadata and context that is available now with the apps as to where they're running. And so this is essentially, the next generation of metrics, right? Which are not just the metric values, but also you've got to know what the context is behind those metrics. And we surface these contexts in the form of attributes. And attributes allow you to create your own views inside of APM. There's several use cases that attributes help you achieve. The attributes also allow you to create APM universes, for example. APM universe will allow you to onboard application teams, different application teams, as they onboard themselves onto APM. And knowing this and knowing how powerful this attribute model was, we also enhanced our Java agent, for example. There's a new extension that you can use with the agent to also populate or publish any custom metadata around the apps. Right? A lot of the customers that I speak with, they use the extension to publish any information that is very specific to their enterprise, right? So perhaps, how the teams are organized or structured internally within that company, right? So you have different application teams, maybe they're grouped by business units, etc. Maybe there is a code, some kind of an application code which is associated with that team. All of this additional data can be published via the attribute extension. So the attribute extension allows you to publish that. So it is published along with our Java agent. It's a Java agent extension that you can use to pass these attributes. The attributes will then show up along with all the other attributes that the agent automatically discovers and reports. And then, like I said, these then allow you to create your own perspectives or views inside of APM, which essentially kind of mimics, how you are structured within your organization, or how the applications are structured or organized within your organization.
Yeah, and it definitely becomes more important as we start moving into the world of containerized applications. Nishant's going to deliver a demo towards the end of this presentation around how we're uniquely managing a containerized application environment. So this is also another, I think, really compelling area, especially when we start getting into more of a self-service delivery model. And, you know, in particular, Nishant, maybe you can give some examples of how our current customers are using this today.
Yeah. So on the Docker monitoring, right? So as you know, there are images that we publish out in the Docker Hub, and if you're using say OpenShift, for example, then there's also an image that is certified and published inside with the Red Hat Container Registry. So in addition, what we also did, along with the Docker monitor images, is also publish image which also includes all the other extensions that all the other extensions of monitoring that APM Infrastructure Agent provides. Right. So APM Infrastructure Agent is essentially, if you've not used it yet, right, it's an agent that combines all the non-application monitoring, so web servers, databases, container monitoring, host monitoring, right? So all of these are part of the APM Infrastructure Agent. And now with this, with these additional images, now these allow you to very easily deploy APM Infrastructure Agent as a service in your Docker cluster or Kubernetes or OpenShift clusters. And additionally, also now, since the infrastructure agent consists of all these different extensions, you can also very easily enable them and start monitoring the other layers of the infrastructure as well. Mm-hmm. And all of these are, again, these images, they're all published in the Docker Hub, so you can download them directly from the Docker Hub.
Yeah, and especially since it runs as a service, it connects with the orchestration tool like Kubernetes and an OpenShift platform. It can automatically scale then with the environment. So that's another, added benefit. The other thing is it really helps to simplify that onboarding process and to be able to manage these dynamic environments very quickly. So, this is something that can be rolled out as part of your application lifecycle from a development to a staging to a production environment. And now you have all of a sudden this seamless monitoring experience that goes across your entire life cycle. Okay, so in addition, we also added, we talked a little bit before about Cloud Foundry. So we had Cloud Foundry before support. We've added additional Cloud Foundry metrics. This screen looks a little crazy, I know, but this kind of gives you also an idea of some of the attributes and the power of attributes that Nishant had talked about earlier. Nishant, what are some of the areas in which we added additional support for Cloud Foundry?
Yeah, so on the Cloud Foundry side, right? So as we were explaining some of the Docker views earlier, Cloud Foundry support is extremely similar, right? So as you deploy applications inside Cloud Foundry, the applications run under the hood. They're running inside the Cloud Foundry containers, right? And we had the support of monitoring the performance of containers, the cells that the containers run inside of Cloud Foundry, and with the performance correlation and also the application topology, etc. And now what we've done is extended this visibility into some of the other aspects of the Cloud Foundry platform. So for example, the Cloud Foundry BOSH, for example, if you're using, every Cloud Foundry deployment will use a BOSH. So now providing performance of the BOSH, some of the other components like the database, etc. So the bunch of visibility or enhancements to the visibility on the Cloud Foundry side, and all of this help you to view and manage the health of your Cloud Foundry platform, right? How the Cloud Foundry platform is working, what are the most important parts of your Cloud Foundry platform, or what are the most important components, and what are the health of all those different components. The next one is Kafka. Again, Kafka is gaining a lot of adoption, especially if you're ingesting a high throughput data stream. The Kafka is very popular for those use cases. The APM Infrastructure Agent also now has the ability to monitor your Kafka brokers, and essentially this allows you to, again, APM Infrastructure Agent will automatically discover the Kafka brokers and monitor these Kafka brokers. And if you enable also the host monitoring of those brokers, then you also get the broker performance along with what is the performance of the host, right? So for example, if say a host where the broker is running on, say the host itself is running out of disk space, for example, then that will have a direct impact on Kafka's performance. So being able to see those, and again, in addition, also the attributes, right? So for example, if you're, there are two ways to deploy this extension. You can connect to this via your Zookeeper, which is managing the Kafka brokers, and that way we'll go and discover the brokers automatically through the Zookeeper. Or you can also go and deploy this APM Infrastructure Agent on the Kafka brokers individually. So again, an enhancement. We're also working on the next phases of enhancing our Kafka monitoring and also just a generic GMX monitoring, where you can remotely monitor the performance of systems like GMX systems like Kafka.
We also added support for MuleSoft as well as extending capabilities around Oracle database. Okay. As a reminder, if you do have any questions, you can put them in the chat or in the Q&A section. We do have a question. It's more of a roadmap question, but one of the questions is why is CEM removed from APM? And there are a lot of limitations. CEM is a great product, and it has a lot of rich information from a real user experience perspective. There are some limitations that customers have found with CEM, and the fact, especially when you're moving into like a cloud-native application, it's very difficult to get then a real user experience out of that. So we have been working on new technologies and new ways in order to get those same results of how can I get that rich real user experience information, but without requiring a network tap in order to get that information. So we will be providing more information about that. Like I said, this is more of a roadmap feature. I think CEM is still available as part of APM, but like I said, we are working on new technologies that help to address this same issue of real user experience information, but more from a cloud-native application perspective. We did have a roadmap session that was available on communities yesterday. We do run these roadmap sessions on I think it's the quarterly basis that we run them. So within the next couple months, we'll have another roadmap session as well. Nishant, anything you want to add to that?
No, I think you covered it, Amy, right? And then CEM is, CEM is still available in APM, but we're also taking that functionality and bringing it also inside of APM. And then essentially our focus is around making it much more simpler to deploy deploy the CEM monitoring. And also, we're also working on things around machine learning and those things to automatically discover, for example, the business transactions or defining those business transactions, which is more aligned with how the applications are written nowadays.
Right. And if you are a current CEM customer and you're interested in what Nishant and I just talked about, we're always looking for design partners and people to be part of the beta program for what we were just talking about. So if you're interested in that, you can go ahead and send Nishant or I a private chat with your email address, and we will get you signed up for that beta or design program. Okay, so now we're going to talk a little bit more about container monitoring. We have spent a good, Nishant, I think it's been like 3 years since we've supported containers, but it has been an evolution and a journey in supporting containers. There's a lot of strange nuances with inside of container environments. We're working directly with very large customers in helping to tackle those challenges that we are seeing, So as a result, it's kind of morphed over the past 3 years in the level of sophistication and the ability to monitor these really complicated ephemeral environments. So for many of you on the phone, we actually did a survey to IT professionals just to kind of gauge where people are at in their adoption of containers. And it was really interesting in the fact that this even matches up with Gartner's research as well, is that they're about 52%, or about half of the people that are surveyed are just getting started down this path. And the majority of people are still using containers more in a dev stage than in a production environment. But what we're seeing with customers that have moved down this journey of adopting containers inside of their application practices is that once it gets into dev, it rolls out very quickly into production. Because of the nature of the portability aspect with containers, it is a lot easier, and those barriers of moving them into production have been removed. So the portability aspect of it has definitely helped with that adoption of containers in a production environment. What was also interesting, we asked this question about, okay, now if for those of you using Docker containers, how do Docker container performance problems affect your business? Which is really uncovering how much insight do you really have into understanding the performance of your applications that are running inside of a container environment. And not just your application, but it could be various different services or even threads or even various different processes. Do you really have enough insights into what's going on? And interestingly enough, of course, 56% said we're not monitoring containers for any kind of business impact. Those that we're seeing longer triage times because they probably weren't getting the right level of visibility into those environments. That was causing deployment delays and also suboptimal performance. So really, why is it so difficult to get information and insight into these complex environments? And surprisingly, majority of the respondents said that there was a skills gap in monitoring and managing these environments. Because they are so different, because they're managed in a different way, because they're so ephemeral, there's just not enough skills and understanding to be able to fully get the insights from those. And then, of course, determining the root cause of an issue, because they are so highly dynamic, it's very difficult to pinpoint where the problem is coming from, whether it's from the container or from the underlying infrastructure that it runs on, or from the host, or from the application itself. There's a lot of complexity that gets involved when you're looking at monitoring these environments. It's not good enough just to monitor the container, but you do have to monitor all of those connection points inside of that environment in order to understand where that root cause is coming from. So that brings us to our solution of what Nishant is going to demo today. And we look at containers from a way of we need to provide complete visibility. So Nishant and I talked about the model. We need to have a way to be able to pull all of this information into a graphical typology that is very dynamic, that is time series oriented, so that we can understand the correlation across the environment as it changes. We also, as I mentioned, time is huge in these environments because even the smallest changes within inside of container do need to be tracked because that could have an impact. And not just the changes within inside of the container, of a container moving from one host to another, but also any code changes that go out into these environments. Because once, as we found with our customers, once they start moving in this direction of adopting containers, they also move in the direction of CI/CD, which means they're pushing more code out into the environment much more quickly. And so that then also becomes important in understanding what kind of code changes are occurring within my environment and what kind of impact that might have to my overall end user experience. And then, of course, we're looking at this from how can we apply intelligence to this layer, because we do need to be able to apply richer intelligence because the problems are slightly different than what we've tackled in the past. So dynamic baselining and being able to look at, to signal out some of the noise the graphical typology model, pattern analysis, and correlation capabilities that then build into an engine that provides workflows for you to be able to understand where culprits are coming from within that environment. And then, of course, flexible monitoring. Nishant mentioned this before. Having the agents being able to deploy with inside of container itself so that you can start acting as monitoring as a service within these environments really help to reinforce, the whole CI/CD process and having more of like an agentless perspective and being able to have monitoring as part of the process and not just something that's bolted on later. Okay, so with that, Nishant is going to give a demo and kind of pull all these pieces together that we talked about. Oh, I got to make you a presenter.
Yeah.
Okay, I'm passing you the ball right now. All right. You never know with live demos. Good luck.
All right. Can you confirm if you can see my screen?
Yes, I can see the experience views.
Okay. So before I dive into my demo, let's just quickly explain the app that I'm using. Right. So I'm using an application, a fitness application, which is rightly called Unfit, that we developed in-house. Essentially, it's a fitness app, allows you to add activities, etc. Right. And then this app itself is deployed in AWS. It is a microservices application which is developed using technologies like Java, Node.js. Also uses a SQL database and also a NoSQL database as well. And my demo, the platform that I'm using for demo is running in a Docker Swarm-based environment, but anything that I show completely applies to Kubernetes, OpenShift, or even say a brutal cloud Foundry, for example, right? So all of these use cases that I'm going to be demonstrating will apply to all of those different platforms. So right here, let me access one of the transactions. So we know there's that as I pull up my activity list, I can see a slow running app right here, right? And that took a long time to just display, right? So let's open up APM and see what's going on with this application. So as soon as I open up APM, I see the experience view. So you may already be familiar with the experience view, right? The experience view, we built an experience view especially for environments like a microservices environments where you could have the hundreds of services, right, and applications. And the experience view allows you to essentially summarize what the experience is across all those different applications and services, see what the experience is, and if the experience is poor for any of these apps or services, then quickly drill down into the root cause, right? Quickly see, what is the root cause for that poor experience. So in my case, I'm going to drill down into the Unfit app. So there are different levels you can also build in this experience view, right? The experience view, the tiled view that you're seeing, it's very easy to personalize this view or configure this view. You can build several levels of drill down into this. So let me jump into the Unfit app, right? And right out of the bat, I can see that Unfit app is experiencing issues. There are over 1,000 transactions which are marked as slow transactions. And I can also see there are some problems and anomalies also detected by APM. So let me drill down into this tile. So that I drill down into my app, I can see the different services that make up that application. So user service, activity service, and token service. And I can see that the activity service especially is the one that's experiencing a lot of poor transactions. On the right-hand side, I can see the different problems that APM has automatically detected with that service. So this is essentially coming in from our assisted triage root cause analysis engine. And as Amy was explaining earlier, right, this is all our the machine learning taking in all the events from both the application and the infrastructure and applying machine learning algorithms to detect what the problem is, right? And we've also added in problem patterns that we have seen at in different customer environments and what the pattern is. And so essentially, so one such, let me walk you through one such use case. So I can see two problems here. The second problem here, I can see that there is, the application is making a lot of database calls. So that looks like a database issue. So let's look into this. As I select that problem, again, I can go and see what the problem is. I can see what is the impacted URL, and then what are the additional details around the problem. So I can see there is a container that has an issue, and then also looks like there is also an event on the infrastructure side, right? So let's drill down into this quickly. I can also see how long has this problem been going on. So right before our demo today, I went and triggered this problem scenario. So you can see that this has been happening since last hour and 55 minutes. So let me open up the analysis notebook. So as I open up analysis notebook helps me, helps the user bring in all the information, be it from application events, be it infrastructure events, into a single notebook, right? So this is the analogy that Amy was making earlier with a detective in a crime scene, right, where you're trying to now find out where the culprits are. So again, I see my problems here, and I see the topology. Now this topology is, like we were explaining earlier, this is a dynamic model, right, that APM is, since APM is constantly monitoring every single transaction, we're automatically creating this model. This model includes not just relationships or dependencies from an application standpoint, which is one application service dependent on another application service. It also maps relationships from application to infrastructure, right? So let me show you an example of that. So for example, if I switch my perspective right here, let me move that. Okay, so let me move it to application infrastructure. So right here, I switched my perspective to show how this is linked to an infrastructure. So right out of the bat, I can see that my app is running inside an EC2 instance. As I open up that instance, we also have the host monitoring enabled on that instance, so we can see what host it is associated with, and inside that, I can see that this particular problem that I'm looking at is related to applications that are running inside two containers. So there's the activity service making a call to a data engine running in two different containers, and as I keep expanding or keep drilling down, I can see additional visibility. Now I can actually go down to what's exactly happening inside the container, right? So this is how we stitch the dynamic model. Now, while this is all great, right, but in reality, your microservices applications are going to be extremely complex, right, with a series of calls going from one container to another container or one service to another service, right? Then how do you triage in such a situation? So we built assisted triage. Assisted triage does three main things, right? So assisted triage first creates a problem. So assisted triage is constantly watching at all the events that are generated inside the system, right? Be it the application events or infrastructure events, and it creates a problem based on an impact of an event, right? So if there is an event or an alert that caused a poor experience with the application, the assisted triage will create a problem for that event. Because it's extremely important to correlate an event to a problem, right? So if you have an event, but the application experience isn't poor, then that event perhaps is just some anomalous behavior, right? So, but a problem is something which impacts the user experience. So assisted triage first defines the problem. It then also brings in all the events. It summarizes that problem by bringing in all the correlated events in that problem chain. So I can see events, all my application events together, and it also correlates all the infrastructure events, right? So for example, you can see that the memory is high, the host CPU is high. This is an event coming in from our own host monitoring. We also integrate with CloudWatch for AWS monitoring. So we also bring in metrics or metrics from CloudWatch, and we can also see that CloudWatch is also reporting the high CPU utilization in this case. So these are the infrastructure events coming in to assisted triage, right? So it defined the problem, it summarized the problem by bringing in or correlating all the events under that problem. And then the third thing that assisted triage does is also identifies now where in this complex microservices chain, where is the culprit, right? Which component is essentially the one that could be the potential cause of the slowness in the app, right? Or could be the potential root cause for this problem. So as I click on this, there are, again, I can see two culprits here. So one is an application culprit. So right here, assisted triage is telling me, let me expand this so you guys can see this better. So right here in this chain, assisted triage is telling me that the service implementation looks like is the cause of the bottleneck, and we can go and then also in addition, there's also a problem with the infrastructure, right? So let's look at what's happening with this service implementation. As I go down, I can now look at the metrics for that service. So it's a Spring service, MVC service. I can look at the response time, for example. Sure enough, right? Looks like my response times are trending higher for this service. It's now close to 11 seconds for the response time, which is extremely high. I can also notice that I can also see this in correlation with differential analysis. Differential analysis is also detected. Differential analysis is our automated baselining, right? So we're also baselining the performance of this service, and and we can see that this is deviated from the normal performance, right? So the red here, the red shading here, indicates that this performance is deviated from a normal performance, right? So green means green is a typical performance, and red is where it has deviated from the performance, and we can say that it is continuously trending up. I can look at some other metrics here. For example, I can look at responses per interval. There are quite a high volume of calls to this service. The next thing that I probably want to know is, I can do a quick time comparison. I can compare, how is the performance, how is it performing today versus say maybe yesterday, when I know that my performance was fine, right? So it looks like the issue only started to happen today. Yesterday the performance looks all fine in this case. The next thing that I want to know is, now since I know that this Spring MVC service is problematic, where exactly is the problem, right? So the APM, I can go and now pull up stack traces. APM automatically collects stack traces, or the agents will automatically collect a trace when there is a problem. And I can go and open up this stack trace, so I can see that there is a stack trace that was generated, just 15 minutes before our call today. So as I open up one of this stack trace, I can actually see the call path. So I see that this is again a transaction that spans across two services. I can open up the service here. I can go through the exact method call path along with the line of code. I can navigate through this. It looks like in this case the call went from the activity service, went through a backend web service call and hit one of our backend data engine calls. And as soon as I go to the data engine, looks like the heavy lifting for this transaction is being done inside the data engine, right? So and as I navigate to the data engine, I can, again, this is my the Spring service that APM or assisted triage indicated as a problem. As soon as I select the Spring service, I can immediately see below this, I see a series of calls. Even right here, I can see there are 1,200 calls going out from the Spring service. And as I open this up, I can see, what are the nature of those calls. I can see there are a series of backend database calls, right? Calls going to the database made by that Spring MVC service. Essentially, this is an example of a death by 1,000 paper cut problem where from the code, it's making a series of calls to the database. So while the performance of every single database call itself is fine, but the sheer volume of this database calls is now causing an issue with the Spring MVC service. So right here, I can see now, that the Spring MVC service is a problem. Here is the exact method is the get by user ID, and then also, it's on this where inside the source code is that problem, right? So now, since I know that this looks like a problem with my application code, next thing that perhaps you want to know is, what suddenly happened with this code, right? If things were fine yesterday, what happened? Why is this problem occurring today, right? So I can also go and check and see if there were any. I can go and check the performance characteristics of this service implementation or this Spring MVC service. I can see there are a series of alerts. I can also go and check if there were any changes associated, right? If there are any events associated with this method. It looks like in this case, there was a new code that was pushed into yesterday, and right after that, we're starting to see a series of performance issues. So this is an example of where we can also integrate with the build systems and also bring in, for example, a build number, right, inside APM. And you can also, essentially this then informs you as you're doing a triage as to what changed in your environment, right? So in this case, the source code did change for this method. And right after that, you started seeing a series of performance issues. So this is, how we can quickly arrive at, what the root cause is. The next piece is, also notice there is also the infrastructure component, which had a high CPU utilization. So we can also go and quickly check what's going on with the infrastructure. So I'm going to quickly switch to the map view, and remember that we said earlier that APM also does we have the same dynamic model allows you to pivot from one context to another context. Since I'm looking at an infrastructure problem right now, I switched to my infrastructure context here. I can go and open up and see again the same view here. I can see the EC2 instance here. I can see the host. I can see the additional details now. I can see some attributes around what is my container application called inside of Docker. Different orchestration platforms have their own way or different metadata. So for example, if you're using OpenShift, then the OpenShift project or an OpenShift service or a Kubernetes service. So all of those are automatically discovered by APM. I can go and check on the host. I select the host. I can go and look at what my host metrics are. So in this case, I did trigger an alert on the host metrics. It looks like the total utilization is high on this host metric. Now, imagine if that was a problem with a host, and the next thing that you want to know is what services could be impacted by that host, right? So what I'm going to do is I'm going to clear out this problem filter that we are looking at. As I've selected that host, I can go and quickly go into my application tab. I can check what applications are running on that host. I can also go and check from a Docker-wise what Docker services are dependent on that host, right? So as I switch my view to Docker, for example, I can go and look at the Docker services, right? So there are two services that would directly be impacted if that host ran out of memory. And again, here is again an example as I'm navigating through the different attributes that we collect, right? For example, if you want to go and look at the Docker images that your applications are based on, I can go and quickly look at that from a Docker image-wise. So here are my Docker images. Just from a performance-wise, I can look at what my container performance is, what my host performance is, what my EC2, even my EC2 performance is, right? So I can also go and look at what is the performance reported from via the CloudWatch metrics for that host. in addition to all the additional attributes and metadata for that host. So I can also, for example, go and check what my instance type is, where is it running, what's the availability zone, et cetera, et cetera. So that, yeah.
Yeah, it was great, Nishant, very thorough. One thing I want to note is that you can see the power of APM here. You can see, like, from a very simplified view where you can just look at experiences to what my culprit might be, giving me at a very high level and very quickly the performance of my application as well as where might be the root cause of my problem, to really the sophistication of APM, which is what Nishant was showing you with the various different layers and the attributes and all of the rich diagnostic data that gets correlated to produce that very high-level simplistic view. So at this point, we have about 2 minutes left in our webcast. There doesn't look like there's any questions in chat. If you do have any questions, you can post them in chat, or you can unmute yourself. We'll give it just a second.
Amy, there are some questions in the Q&A box.
Okay, great. New WebEx, really? Okay, question and answer box. When I see, maybe it's just Octavie. Maybe it's just you that can see the questions. Nishant, can you see the questions in the Q&A box?
Yeah, I just pulled it up. I didn't realize there was a separate Q&A box. So I can see, so the questions around CEM. So we'll get back. So the question from Manish around signing up Manish for the design partnerships. Absolutely, we'll do that. We'll go ahead and connect you, Manish, with the right teams. APM SaaS alert integration. So I'm not sure if that's a question or a comment, but there are improvements being done around the alert integration in APM SaaS. We're also adding new notification types, for example. So again, if this is a topic of interest, do let us know. Reach out to us. We're also building, for example, integrations with ServiceNow, and some of those things are also available. So we'd love to, again, sign you up as design partners. Another question is, how do I baseline the issues for alerts? So there is, again, automated baselining. If you're using differential analysis, for example, it's automatically enabled for all the front ends and the application components. And you can go and trigger, you can go and configure the sensitivity of our baselining. What is the difference between APM SaaS Infra Agent and the UIM Infra Agent? So that's a great question. So just real quickly, the APM Infra Agent provides, the visibility into all the different tiers of infrastructure, right? Essentially, our goal with the Infra Agent is provide you with just enough visibility that lets you rule out whether app is a problem or infrastructure is a problem, right? So once you identify that infrastructure is a bottleneck, then you can do some high-level root cause inside of APM. But at that point of time, if you're saying, if you want to deep dive into infrastructure, then you will dive into UIM and then do a more deeper root cause analysis with the UIM agent. From a code-wise, there are some. We also share some of the code with the UIM agent. If you're using the UIM probes, then the UIM probes can also integrate with APM, so they can also send in the events and alerts inside of APM. They're also integrated with the triage, etc.
Yeah, I think with that one, it's just the level of information that you want from the infrastructure. UIM is an infrastructure tool. It provides you diagnostic information down to a granular level. The infrastructure agent in APM is more of like a high level diagnostic information that's pulled in. Any other questions, Nishant? I can't see the Q&A box.
No, I think that was it. That covered all the questions.
Lots of great questions. Thanks for everyone's attendance today. Really appreciate you listening to this webcast. We're going to try to do more of these in the future just to kind of keep our community up to date of what all the great new enhancements are with inside of APM. I want to thank Nishant Cabra here today for the excellent demo and the great conversation today, and then of course our community's champion, Octavie, who always helps us with setting up these events. So once again, thanks everyone for attending and have a great day.
Thank you. Have a great day.